Hello, I'm James Sherry and welcome to Mission to Planet Earth in this, the United Nations International Year of Space. Mission to Planet Earth is a series of projects involving scientists from around the world. They're trying to find out more about this planet that we live on. Mission to Planet Earth started as an idea in the United States. It was a way of celebrating the 500th anniversary of Christopher Columbus sailing out into the New World. It's also the 35th anniversary of the launch of the first satellite into space. To assist me in telling you more about Mission to Planet Earth, please welcome my computerised cobber, Aussie Cosmo. G'day, Aussie.
Greetings, humanoid James, and greetings, humanoids around Australia. My circuits are buzzing because I've been programmed to help tell you about space exploration and the significant role Australia has played.
That's right, Aussie. We'll be taking a journey back through time to find out how space exploration began. You know, Aussie, when I think of space, I think about those fantastic science fiction movies like the Star Wars trilogy or the Star Trek sagas where they boldly went where nobody had gone before in order to seek out new lives and new civilizations. But space isn't just what we see in the movies or on television. You know, we're doing things today that would have seemed like science fiction stories not that many years ago. Let's go back in time, shall we? Back to the beginning, when space was the stuff of myths and legends.
The night sky had always held a fascination for people. Regardless of where in the world people were, the stars they saw at night needed some explanation. Aborigines had legends and myths to explain things. These stories and the corroborees and paintings they inspired helped make up a rich Aboriginal culture. Ancient civilizations like the Egyptians, Greeks and Chinese were mapping constellations 6,000 years ago. In fact, they knew more about the heavens above them than the world around them. The science called astronomy sought to separate the facts from the myths, and it began with the great ancient civilizations. You may have heard of a man called Pythagoras in maths classes. He was a Greek mathematician who had a thing for circles and spheres. He was also the first person to claim the Earth and all the stars and planets were round. That was 2,000 years before Christopher Columbus proved the Earth wasn't flat by sailing to the New World 500 years ago.
Well, what about that Pythagoras, hey? He must have been really switched on to have been so far ahead of his time.
Affirmative, and as the years rolled by, other astronomers continued the work started by Pythagoras, coming up with theories so radical that they were often ridiculed and sometimes even imprisoned.
Well, even Christopher Columbus was heavily paid out on. All the people of his time thought that he would sail right off the edge of the world. They all thought it was flat. I guess nobody really knew what the great explorers would find as they ventured into the uncharted territories with nothing to guide them but the sun and the stars.
Affirmative once again. All the great navigators used the stars to sail the seven seas, and one of the greatest was Captain James Cook. His most famous voyage is the best place to start looking at Australia's involvement in space.
It could be said that Australia was discovered by Captain James Cook because of space exploration. His major mission when he left England in 1768 was to sail to Tahiti to observe the planet Venus pass between the Earth and the Sun. Scientists in England wanted these observations recorded so that they could work out how far away from the Sun the Earth is. After completing his mission, Captain Cook sailed the Endeavour southwest to eventually land at Botany Bay in 1770. When the first fleet arrived in Australia 80 years later, there was a Captain Dawes on one of the ships. He set up an observatory on what is now called Dawes Point in Sydney. He studied the stars to work out his exact position in relation to the rest of the world. His studies helped explorers draw maps of the new land and to calculate local time. Astronomy was also important to Australia's identity. If you take a look at the Australian flag, you'll see that there are 6 stars. The 5 smaller stars represent the Southern Cross, a constellation that can only be seen in the Southern Hemisphere. That should give you some idea of how important astronomy is. It not only helped open up the new land of Australia, it also helped shape our national identity.
Now, who would have thought that Captain Cook was Australia's first link to space research?
I guess that's why Australians have always found it important to have a Captain Cook at the stars. And what about Captain Dawes? You could say he opened the window on space. Get it? Dawes opened the window. That's a bit of cosmic comedy.
The space age as we know it really began after the Second World War. Advanced technology used for the war effort showed how small the world had become. Jet aircraft could travel faster and further than ever before, and rockets had been developed to the point where scientists were convinced that they could be shot into space. People were looking beyond our planet. They were looking to the stars. 2 nations, the United States of America and the Soviet Union, led the space race from the beginning. These 2 superpowers realized how important conquering space would be from a strategic and military point of view. They knew that to be the most powerful nation on Earth, they had to be the most powerful nation in space. In 1957, the Soviets got the jump on the Americans by launching Sputnik, the first man-made object in space. The American government thought the best way to compete with the Soviets was to be the first country to put a man in a rocket, launch him into space, then bring him back to Earth. But once again, the Soviets were too quick, and a Russian cosmonaut called Yuri Gagarin blasted his way into the history books by becoming the first man in space. Shortly after Gagarin's amazing flight, astronaut Alan Shepard became the first American in space. That success prompted US President John F. Kennedy to make this prediction.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Even though he didn't live to see it happen, Kennedy was right. On July the 20th, 1969, Neil Armstrong set foot on the moon and spoke these famous words.
It's one small step for man, one giant leap for mankind.
While the USA and the USSR were blasting rockets and people into space, other countries weren't just spectators in the space race. And Australia was ahead of the rest. We were the 3rd nation to launch its own satellite into space from its own territory. Our first flirtation with space was in 1967 with a satellite we called RESAT. It was launched from a site in South Australia called Woomera. That's an appropriate name since a woomera was a stick used by Aborigines to allow them to throw spears faster and further. The launching of RESAT was a remarkable feat for Australia, a young country in terms of technological achievement. After this success, we concentrated our efforts on joint projects with other nations, particularly the USA, and its National Aeronautical Space, or NASA program. And we were a big help. Those television pictures of Neil Armstrong were beamed to Australia first. That's right, they were received at the Honeysuckle Creek tracking station in Canberra, which was the prime station for the Apollo 11 mission. But the moon was just the beginning of the new frontier. While it's as far as any man has ventured into space, unmanned space probes have been sent to the very end of our solar system and beyond. In the late 1970s, the Voyager spacecraft started a grand tour of the outer planets, passing close by Jupiter, Saturn, Uranus and Neptune, and have sent valuable information back to scientists here on Earth. Because Uranus and Neptune were both high in the southern sky as the Voyager craft flew by, virtually all the priceless data sent back was received by tracking stations here in Australia.
Just to give us an idea of how big space is, Aussie, can you compute how far it is from Neptune to the Earth?
Neptune is 2 billion kilometers from planet Earth, give or take a few million kilometers. But space is a lot bigger than that, you know. It's infinite.
Which means it keeps going and going and going forever.
Affirmative, which also means it doesn't matter how much you humans learn about space, there'll always be more to discover.
Ah, but Australia is playing a big part in learning more.
In terms of location, Australia is one of the world's most isolated countries, and for this reason, communications are vitally important to us. Australia is one of only 6 countries with its own domestic satellite network, which gives us independence and freedom of communication with the rest of the world. Our satellite communications began in 1964, when OTC began transmitting signals between Australia and other countries. It enables ships to navigate around the world and maintain contact with the mainland. And it makes it possible for scientists stationed at bases in Antarctica to communicate with Australia. We also have one of the world's most advanced domestic communication system, thanks to other satellites called AUSAT. Because of AUSAT, people on remote outback stations can watch television, listen to the radio, and make telephone calls anywhere in the world. We have state-of-the-art facilities that can provide and process data that few other facilities in the world can provide. Let us take a look at these and how Australia is helping the world to better understand space. Tidbinbilla is a tracking station in Canberra. Tidbinbilla is an Aboriginal word meaning a place where boys are initiated into manhood. It's a place where Australia has undergone its own initiation in the space age. This station tracks spacecraft, measures its distance from Earth and the speed and direction it's travelling. It also collects data sent back from the spacecraft and allows for instructions to be sent from the tracking station to the spacecraft. Tidbinbilla has supported a great number of American projects and every day throughout the year keeps in contact with many spacecraft such as
Photographic images and scientific data received from Neptune, August 25th, 1989. Distance from Earth, 4.5 billion kilometers. Signal takes 8 hours to reach Earth, traveling at the speed of light.
Pioneer 10.
Most distant spacecraft from Earth at 8 billion kilometers. Data received, instructions sent.
Magellan.
Currently orbiting Venus. Radar mapped images of planet's surface received.
Galileo.
Destination Jupiter, the biggest planet in the solar system. Speed 70,000 kilometers per hour. ETA 1995.
Ulysses.
Launched October 1990. Mission 1, record and transmit information on Jupiter. Mission 2, orbit the Sun's poles to provide scientists with the first 3-dimensional view of the Sun.
The Tidbinbilla tracking station works with similar stations in Spain and California to form what's called the Deep Space Network. Parkes Australia Telescope and its 64-metre dish is a symbol of Australia's involvement in modern astronomy. It has also played a role in the Apollo missions to the moon during the 1960s, especially in the 1969 moon landing and the rescue mission of the Apollo 13 astronauts when their spacecraft ran into trouble while orbiting the moon. It has also been linked to Tidbinbilla to receive information from other NASA missions into space and those of the European Space Organization and Japan, including the Voyager exploration of the outer planets and the Giotto satellite, which investigated the famous Halley's Comet. The telescope at Parkes works with other telescopes in Australia and around the world to help us reach further out into space and increase our knowledge of what goes on out there. The Australia Telescope consists of 8 dishes located throughout Australia. 6 of these can be found at Narrabri in northwest New South Wales. All these dishes are linked together to create what amounts to a huge antenna that's able to receive the faintest radio signals from space. Today, Southern Sky Astronomy is breaking new ground with, for example, facilities like the Anglo-Australian Telescope on Siding Spring Mountain in northwest New South Wales. It's here that objects in deeper space are detected. Objects like quasars are the most distant objects from Earth that we know of. The discovery of others, like the stars in the galaxy shown here, may one day give scientists clues about how our galaxy, solar system, and the Earth itself were formed. The technology required to produce these images was developed by scientists working at the Anglo-Australian Telescope, a great feat for the land of the Southern Cross. Scientists from all over the world came to Australia in 1987 to observe a supernova. A supernova is a dying star, And 1987 gave scientists the first chance to view one since the invention of the telescope 400 years ago. By studying this supernova and the radiation it emitted, using facilities at the Anglo-Australian Telescope, scientists hope to gain a clearer idea of our solar system's origins and the secret to life on Earth.
You know, the first photographs of our planet gave humans a chance to see what a beautiful and fragile place it really is.
That's right, Ozzy. And we came to realise how much we affect our environment and how we have to make more effort to look after what we have.
Australia is playing an important part in this with the development of a world-class remote sensing system. This system is our eye in the sky, which can see what's happening to our planet. Orbiting just 700 to 900 kilometres above the Earth's surface, satellites monitor our environment, sending information back to Australian ground stations. These satellites tell us how much damage has been caused by natural disasters like earthquakes. They detect environmental changes like how the climate varies or how the temperature and levels of our oceans fluctuate. They have improved weather forecasting, so you can find out tomorrow if it will be a good day to go to the beach or whether you might be better to stay indoors. Because of the information supplied by satellites, severe storms like cyclones can be tracked. The Australian Centre for Remote Sensing is also working with the European Space Agency on a project launched in 1991. A new satellite monitoring the Earth's surface was sent into orbit by the European Space Agency and sends back data so fast only supercomputers, such as those invented by Australian scientists, are capable of processing it quickly enough. If this satellite is the eye in the sky, then these computers are our ears on the ground. Ten worldwide Earth science projects are being conducted during the International Year of Space. They're designed to assess global environmental problems which affect us all, even if you don't realise it. Australian scientists are enthusiastic members of the worldwide effort to learn more about our planet. We live on the driest, flattest continent in the world. Most of our country is too remote for ongoing scientific monitoring, so satellite sensing is invaluable for us to understand our ever-changing environment. Another good example is the way satellites help detect the presence of what's known as the El Nino effect. This is the natural phenomenon which leads to the water in the eastern Pacific Ocean becoming warmer than usual. And when this happens, we get droughts in the eastern states of Australia. If droughts can be predicted, governments and farmers can prepare for them. Australia is also involved in the International Forest Investigations Team, which is analysing specific forest areas, including some of our own, over a 20-year period. This will find ways to help our precious forests survive. A similar 20-year study is being conducted on land areas to see what changes there are in such things as the level of erosion, the quality of soil, and how having too many cattle or sheep in an area can destroy the vegetation cover, which leads to worse erosion. The ultimate goal is to gain a better understanding of our planet and its resources and how to protect and preserve our environment.
So you can see how space exploration just doesn't necessarily mean going further into space, but how it can be used to look back at ourselves.
Yeah, it's like being on the outside looking in, you get a whole new perspective. But you know, there's other benefits from space exploration, like the things that have been developed through the space program that we now use every day. These are called spin-offs, and they include things like Velcro, which was used to stop things floating around in the spaceships because of the weightlessness of space. Superglue was used for temporary maintenance inside the spaceships. Cordless power tools have been developed by NASA, and even the running shoes we wear today are based on designs used by astronauts.
Affirmative, James. Today people use products designed for the space program in the 1980s, but there are far more important health issues being tackled in space than the ultimate running shoe.
Scientists are carrying out a whole range of important experiments in the weightless environment of space. Experiments that can't be carried out in the Earth's gravity. These experiments include the production of medicine that one day may be of untold benefit. The prospect of permanently manned space stations in orbit with scientists experimenting in the medical field holds the promise of discoveries that will improve our life and health back here on Earth. Space shuttles solved that problem because they can be sent up into space, then come back through the Earth's atmosphere and land just like a normal aeroplane. The space shuttles are used to carry satellites and other equipment into space to orbit the Earth. Australia has used the shuttle to launch the Endeavour, Australia's space telescope, the most advanced piece of technology we have sent into space. What a way for Australia to blast its way into the 1990s, and how appropriate this new and exciting venture into space should carry the name of the ship Captain Cook sailed to Australia in. Endeavour is a working demonstration of the ability of Australian scientists and engineers to design and build complex instruments for use in space. Australians involved in the space program have even greater goals, using the International Year of Space as a launching pad to ensure the Australian Space Office motto, "Making Space for Australia," becomes a reality. There are plans to make more use of the Woomera launch site and to develop a commercial spaceport at Cape York. Cape York Peninsula is that bit of North Queensland that looks like a finger pointing upwards. Maybe it's showing us the way. One thing is certain, if the rocket facilities are built on Cape York, Australia will be in a great position to take full advantage of what space has to offer. The site will be used for commercial space projects. In other words, large companies from all over the world will pay to put satellites and other equipment, called payload, onto rockets launched from Cape York. Projects like this will attract high-tech industries, create jobs and improve Australia's economy. Scientists and engineers claim it's one of the best locations in the world for such a facility because it's close to the equator, where the rotation of the Earth is at its greatest and can help launch a rocket into space, a little bit like a slingshot.
So what have we learned today, James?
Well, we've learned about the history of space exploration and Australia's involvement. But, you know, the most important thing I've learnt today is not about the machinery or what's out in space, but it's about people. No longer do we look at this planet as just a group of continents or countries, but it's one big place where we all live. And it's time that people started looking at everything on a global level. Environmental problems that happen in Australia aren't just our problem, they're everybody's problem. Just as environmental problems that happen in other countries concern all Australians, even mechanical ones like you, Aussie.
And everyone can be a part of the solution to the problems too, James. Who knows? Maybe one day you'll be involved in Australia's future in space as a scientist or even an astronaut.
Yeah, right. Well, for anyway, now, Aussie and all Australians, we're out of time, even if we're not out of space. But remember, in whatever you do, shoot for the stars. Oh, wait, before you go, I have a special message from Australia Post. To celebrate International Space Year, Australia Post have launched an exciting new series of space stamps. These stamps feature images of celestial phenomena seen in the southern sky. Helix Nebula is a body of cosmic dust and gases illuminated by the light of stars. It is a dying star located around 400 light years from Earth. The Pleiades is a cluster of stars, also about 400 light years from Earth, 7 of which can be seen very clearly. Spiral Galaxy is very similar to the Milky Way, the galaxy to which our own solar system is part. It is about 25 million light years away from Earth. All of these images were taken by astrophotographer David Malin at the Anglo-Australian Observatory on Siding Spring Mountain. Stamps are also available in a miniature sheet. This shows ERS-1, one of the newest remote sensing satellites to be put into orbit around the Earth. Also available are 3 postcards that include postage. They feature Parkes, New South Wales, the Anglo-Australian Observatory, and the Space Shuttle Discovery, which carried the Endeavour telescope, one of Australia's major achievements. This beautifully produced book is all about our solar system, satellites, and how space missions can help us to learn about our environment. It also features an incredible 3D hologram on the front cover, a space stamp pack, and the first day cover. These products are available at your post office until sold out. So blast your way into the exciting hobby of stamp collecting and buy these new products today.